V0 nj over v. Actually, no, that's not the way I want to write it. I want to write it slightly differently from that. So let's just review for a second. This nj over v is pj over rt. And that's actually the way I want to write it. So this whole thing, n0 over v0, nj over v, I would like to write as n0 over v0. Instead of nj over v, I would write pj over rt. So I have RT N0 over V0. And now I should have a PJ on the denominator. So I'm going to move that into the numerator and write this as the log of PJ. That's the way I want to go. What's that? Yeah, there's all close bracket. Okay, so I want to look at every term here. Let's look at this one term at a time. First I have an RT, okay, that's okay. And now I've got a U0J, it's just a number, it's the function of molecular structure over N0RT. So this is only a function of temperature. This thing is only a function of temperature, T. T. This is a number. It's not a function of anything. S0J over NR, just a number. It's a reference thing. F of U over N divided by R. F of U over N, just a function of molecular structure. And in such a way that its derivative is just a function of temperature. Okay. F prime of U over N, we said that's just equal to 1 over T. So this thing is just 1 over T, U over N. This thing only depends on temperature and the reference thing. This thing depends on other things, PJ, depends on the total pressure. So, and it also depends on the concentration, NJ over N. There are no other NJs here. So all of this is a function only of temperature. Function of temperature only. And I'm going to call that phi j of t. And I'm going to call phi j of t the absolute activity. Of species j. Now, I should be careful. I have to see if I want to put the RT in there. Yeah. Okay. So this tells me that uj is equal to RT, and is that phi j or the log of phi j? Depending on how I want to define it. That's phi j of t. So this is RT times phi j plus the log of pj. I still think the absolute activity is the log of that, but let's see. That's the log of pj. And pj, of course, I can write pj is equal to, well, I know that cj is nj over v. And that's equal to, and v is equal to nRT over p. PV is nRT. So, and this is pj. So this is equal to pj over RT. So I could also note that this is equal to RT times phi j of t minus the log of RT plus the log of Cj. Yes?
Okay, so this absolute activity that you define, does it relate to the activity conditions that you wrote?
We'll get to it. I chose the name exactly to get you thinking in that line of thinking. But right now it's just a name. And I'll relate it to what we know of in terms of activity next time. But there's only one more, it's too bad. There's one more, running out of time, I have like 3 minutes. Okay, so once I have mu j, now I can write out delta G of reaction. And delta G of reaction is when the change in the chemical potential on both sides of the reaction is 0 at equilibrium. So at equilibrium, delta G of reaction is the sum of the beta i's minus the alpha i's mu i's. And at equilibrium, it's equal to 0. So that tells me that the sum on J of RT phi J of T is equal to, or the negative of that is equal to, the sum, I'm sorry, the beta J minus alpha J. Sum on J of that is equal to, so I plug this in here from U. I move this term to the other side of the equation. So I'm left with RT sum J, beta J minus alpha J, log RT, with the minus sign. And then I have the plus RT sum on J, beta J minus alpha J, log Cj. And the left-hand side of the equation is exactly what I'm going to call, define as the log of the equilibrium constant, which, since this is only a function of t, the equilibrium constant is only a function of t. What does the right-hand side look like? Well, actually, before I do that, I think my naming wasn't quite right. Phi of t is not the activity. The activity is defined as the activity of species I is defined as e to the minus phi j. So the activity is in phi, it's e to the minus phi I of t, and the activity is also only a function of t. So let's see what the left-hand side looks like. So this is equal to RT times the sum on J, beta J minus alpha J, times, well, if A is e to the minus phi j, then phi j is equal to minus the log of aj of t. So here the minus phi is just equal to the log of the agent. So it's the log of agent. So notice what I have here. since this is a constant time, a coefficient times a log, I can write this as RT times the sum on J of the log AJ to the beta J minus alpha J. And the sum of the logs is the log of the product. And I want you to look at this and see if this looks familiar. Where I put the AJ to the alpha J in the denominator and the AJ to the beta J in the numerator. So this is the continued product of the activity of the jth species raised to the stoichiometric coefficient on the product side, divided by the activity of the ith species raised to the stoichiometric coefficient on the reactant side. This is exactly what we wrote as the equilibrium constant in your thermodynamics class. And actually, I don't want the RT here, this is RT. Okay. So this is exactly the expression for the equilibrium constant in terms of the activities. Exactly the expression for the activity for the equilibrium constant in terms of activities that you used to see. The ratio of power products between the numerator and the denominator. I don't really want to go on now, even though I'd like to finish this. It's probably only 10 more minutes. But I think it's unfair. So we'll continue this on Monday. So we'll continue from this equation on Monday. But just when you look at coming attractions again, you see we got this power product in terms of activities for the equilibrium constant. And on the right-hand side, I have something that looks similar. I've got a sum of beta minus alpha times the log of something. So this thing is going to give me the power product for the exact same algebra. This is going to give me minus RT times K equilibrium for written in terms of concentrations. This is in terms of activities on the right-hand side. So this term of the exact same algebra is going to give, this is the true equilibrium constant in terms of activities. Here it is written in terms of concentrations with the same power product, but I have another term here. So we'll talk about that next time. Are there any questions? Let's see.
Okay, so you define like the entities, right, in terms of mixing. So I got a little bit confused because I think the way I understood it was, okay, you define it in terms of mixing so that you wouldn't have any depreciation of any components. But then you said this is the definition for equilibrium in terms of reaction, right?
I'm sorry, I didn't understand the question.
Okay, so how I got lost at the point where you started by saying, okay, you have a mixture, and then your components don't degrade with your mixture.
Don't degrade? I
like,
didn't say anything about degradation.
Okay, but then this looks like the equilibrium constant when you have a reaction.
There is a reaction. That's the whole point. This is the thermodynamics of reactions. Reaction thermodynamics. The first word was reaction. The whole point here is this is the thermodynamics of reactions. So I'm trying to figure out the thermodynamics of reactions because it's the equilibrium constant which is going to give me the maximum conversion I can get to. It's going to be a limit, so I want to understand what controls the equilibrium constant, what controls the limits on my reaction. Equilibrium does. So I want to know how will I be able to manipulate that. Just before we go, we've just made up the one class that we missed like a month ago. We also missed 2 classes last week. So the question is, can we do this for the next 2 weeks as well on Fridays? Or is there a time on Wednesday where we could have a second class so that we don't have to come on Fridays?
The second Friday is going to be right after Thanksgiving.
Okay. So the question is, can we do, is there a time on Wednesdays? Like in the, do you have lab on Wednesday afternoon or something? Till what time? From 2. So Wednesday doesn't sound like a good choice. What's wrong with next Friday? Conference. What conference next week?
chef conference in Dallas, coming in Dallas.
Chef, what's a chef?
Hispanic professionals.
Engineers.
Why is it in the middle of the semester?
It's like baking.
Hmm? I will talk about it on Monday.